easiest type of questions in this is when we want to find the last two digits of a number whose unit digit is 1. That could be anything out at the position of star, but the unit digit is 1, right? So try to remember these types of questions in boxes. Unit digit 1, the most easiest, we'll see. For example, let's say find the last two digits in of 7821 raised to 68, which is same as the last two digits of 21 raised to 68. Just as we saw in cyclicality of unit digit, the last two digits will depend only on the last two digits of the base. The other numbers do not have any role to play. So hereafter I would only be dealing with a two-digit number and just ignore the rest of it, right? So 21 raised to 68 could be written as 1. That 1 which is what makes this question very easy is this unit plus 20 raised to 68, right? And I'll use the binomial expansion to expand it. Since this is the first question, I'm writing the binomial expansion in a little more elaborate manner. I'll not always do that. The first term is 68C0, which is of no value is 1. So 1 raised to 68. From next time, I'll not be doing this. I'll just write a 1 plus 68C1, that is 68, into 1 raised to 67, which I'll just write it as 1. The power of 1 is decreasing and the power of 20 is increasing, plus 68C2, this is 68C1, which is 68 itself, 1 raised to 66, the power decreased, power of 20 increased, plus I'll just leave it as higher powers of 20. So as I go further, I'll be getting a 20 cube, 20 raised to 4 and so on. And so how am I going to write it earlier? I'm going to just write it from next time as 1 raised to 68 is 1 plus a 68 into 1 into 20. Okay, plus a 68C2 into 20 square. Now this 20 square will have 400. So the last two digits, these are numbers where the last two digits are 0, plus more numbers where again the last two digits are 0. This is how I am going to write from next time. Therefore, I said you just need a basic understanding of binomial. We are not going to use binomial as much. Oh, this is a very silly question. We want last two digits, mind you. Here the last digit is 0. So 8 into 2, 8 into 2 is a 6 and then there's a carry forward. Again, I'm not interested because the last two digits I found. Let me write this one also as 0, 1. And there are a lot of numbers with 0, 0, which will make no difference to the last two digits, right? So the last two digit here is nothing but 61. While speaking, it makes work so big. There are a lot of classes who just teach you this way. Look at the calculation here, right? Take the unit digit, multiplied with the tens digit. 8 twos are 6 and append a 1. That's it. This is your answer. You might choose to learn it that way. We would still want you to, have this in your mind. So it's pretty straight. 68 n C1, which is 68 into 20. The 0 will go out over here and you'll be left with the 8 into 2. That's it, right? So, not doing it completely. So, if I have 71 raised to 75, all I'll do is a 0, 1 plus 75 into a 70. And all numbers will have more than 2 zeros hereafter, right? So, that's a 35, 51 is the answer. Hope you got that. 5 into 7, 35, 5 and a 1, 51, right? Write it down completely yourself. This is more like an appendix to a chapter, right? It's not a complete chapter in itself. These concepts are learned only when you're aiming at 99 percentile plus. Or forget 99 percentile plus, even 99.8, 99.9 percentile plus. So you need to be well aware with your basic maths, right? So I'm not going to stop and explain each and every point out over here. You would have to do the work yourself, right? If you want just another example, since this turned out to be 51 itself, let's take another example. Let's say 91 raised to 99 or what shall we say 27. So 7 into 9, 63, 3 and a 1. This is going to be my answer, but this should come out from 0, 1 plus 27 into 90 and further numbers which have two zeros in the end, right? So this will become 0, 1. The last two digits of this is going to be 30 and so on, right? So 30 and a 1, 31. Next time.